conservative in 3 dimensions. So the test to determine whether a vector field is conservative is you just take the curl. If the curl is the 0 vector, then it's conservative. If it's not the 0 vector, it's not conservative. So I'm going to run through a few examples of doing that. So here we just have the vector x, y, z. You put it in a matrix. You take the determinant of that matrix to find the curl. So you take the yth derivative of z and the zth derivative of y, right? And you crisscross this way. So you go x and z, z and x, and then you do the k hat, which gives you x and y, right? So derivative of y with respect to x, and then minus the derivative of x with respect to y. And so you can see that this is going to be 0, this is 0, 0, 0, 0, 0. They're all 0. So the curl of this vector field is the 0 vector. So this is a conservative vector field. Here is another example. We have the vector x minus yz, y minus xz, z minus xy. We put it in a matrix and we do the process of finding its determinant. So we take z minus xy, the derivative of z minus xy with respect to y, with respect z with respect z with respect z with respect to z, right? So in order to find the I, we take the determinant of that matrix, and then in order to find the j, we take the determinant of this matrix, and then to find the k component, we take the derivative of this matrix. So here I did that. We go z minus xy over y, y minus xz over z, z minus xy over x, x minus yz over z, and y minus xz over, so k hat, y minus xz over x, and y minus yz over y. So we can do those derivatives. Here we're going to get minus y minus, this is going to end up being minus x, and this is minus x. This is going to be minus y, this is minus y. This is going to be minus z, and this is minus z. So what we get is minus x minus minus x, right? That just comes from up here. So these cancel out, these cancel out, these cancel out. It's the 0 vector. So this vector field is conservative. Here's another example. We have xyz, xyz, xyz. You put it in a matrix, you find the determinant, right? And the determinant gives you this function right here. You can see that this is in general not going to be 0. This in general isn't going to be 0. And this in general is not going to be 0. So this does not equal the 0 vector. So this is not a conservative vector. Where the x component is a function of x and y, the y component is a function of x and y, and there is no z component, and the z coordinate does not show up anywhere in this vector field. So basically we have a vector field that is the same no matter what z value you give it, and it just depends on x and y. So we take the determinant of it, right? We set it up like we do usually. I component is this crisscross, j component is this crisscross. Okay, component is this crisscross. We set that up. This is 0, right? Because you take the derivative of anything with respect to... If you take this derivative of 0 with respect to anything, it's going to be 0. There is no z component in this, so that's going to be 0. There's no z component in f of x, y, so that's going to be 0. So what you have is the vector 0, 0, and then this stuff. So if you notice, this vector is only going to be conservative when this term is also 0, right? So that term is 0. Right, so when this term is 0. Another way of saying that is just this component has to equal this component, and then you can see we get the test to determine whether this is the same exact thing as the test to determine whether a two-dimensional vector field is conservative. Right, it's just a this is just a generalization of this test for 3 dimensions.